Hi everyone, welcome to another module of Generative AI cost optimization. As you may already know, although that Generative AI application can brings a lot of values to the businesses and also individuals, but at the same time they consume a lot of compute resources, which means these types of application can be costly. In this module, we're going to cover the key cost driver of the Generative AI application, which can help you to build the foundation that you need for running any sort of cost optimization. We are also going to cover how you can calculate the total cost of ownership, or TCO, which is the key metrics that need to be used in order to do any sort of cost optimization. So if you are ready to explore, let's dive in.
All right, let's start with some fundamentals about generative AI. Generative AI is a subset of AI focused on creating new content rather than simply analyzing or classifying existing data. Unlike classic AI models, which usually are used to predict an outcome or categorize information, generative AI products usually output things like text, images, audios, or videos. Examples of these applications are like ChatGPT for text or DALL-E for image. There are a number of key technologies behind these generative AI applications. We have generative adversarial networks, or GAN, which are often used for image and video generation by putting two networks against each other. We also have a variational autoencoder, which is known for efficiently generating new data based on patterns learned. The last but not least, we got transformers, which is the foundation for more accurate models like GPT, which are usually excel in processing sequential data, things like text that we have. In businesses and industries, generative AI is revolutionizing different aspects of those. For example, we have companies use generative AI for personalized marketing by generating targeted ads or creating realistic virtual environment for gaming, or even drafting customer support responses. These applications brings a lot of values, including saving time, reducing cost, and improving operational efficiency. As generative AI become more popular, managing costs is a critical challenge. Many organizations, particularly the smaller ones like startups, struggle with the high expenses associated with adopting and maintaining AI applications. When scaling generative AI, costs arise in areas like computing resources, data storage, and model deployment. If these costs are not managed effectively, they can hinder adoption. Smaller companies like startups may just price out of using AI entirely, or it may limit the transformative potential for large corporations. Also, we got this theme around sustainable AI development. This means creating applications that perform well while being cost efficient and environmentally responsible. For example, focusing on energy efficient computing and optimizing resource usage can help balance innovation with practicality. To effectively manage and optimize the cost of a generative AI application, it's crucial to understand the key cost drivers. These drivers influence the overall budget and also help identify areas where efficiency can be introduced. By analyzing these components, you can make an informed decision about scaling, resource allocation, and long-term investment in AI technologies. And here you can see a number of different key cost drivers, things like token usage, data, infrastructure, monitoring, and maintenance, which are usually the key cost drivers of generative AI application. Let's deep dive in each of these individual cost drivers. Let's start with the prompt and token usage. A major cost factor in generative AI is usually token usage, especially for those large language models. Providers like OpenAI charge based on the number of tokens processed during an iteration. We got this concept of token-based pricing, which means costs are directly proportional to the number of tokens processed during both input and output generation. For example, OpenAI may charge an amount per token used and also another amount for the output generation in terms of text. Also, we got this prompt length, which can impact the number of tokens used and also generated. Complex prompt significantly increase token usage and processing costs. Also, techniques like prompt engineering and efficient prompts can lower costs by reducing token needs while maintaining output quality. For example, rephrasing a 200 token prompt to a more concise one like 100 token can achieve the same result and could save nearly 50% on input cost, potentially leading to substantial saving over numerous iterations. The next cost driver is the model. Model size significantly impact costs. Larger model require more computational power and memory, leading to higher training and deployment expenses. While these models offer exceptional capabilities, they may not always be cost-effective. Pre-trained models provide a cost-saving alternative since they eliminate the need for extensive training. However, fine-tuning this model for a specific task can add to the cost. Optimization techniques can also mitigate these expenses. For instance, we got this concept of pruning, which can reduce unnecessary parameters in the model, or quantification or distillation. These are like the techniques that can compress the model and improve the model training and deployments in terms of like the cost. The next cost driver is infrastructure. Generative AI demands powerful infrastructure. High-performance GPUs and TPUs are required for tasks like training models and running inferences. These components are expensive and consume significant amount of energy. Usually, organizations face a choice between cloud and on-prem solution. Cloud computing provides scalability and flexibility, but comes with ongoing operational costs. On the other side, on-prem infrastructure requires significant upfront investment, but can reduce cost over time if usage is consistent. We also have this energy consumption, which is another major cost driver. So if organization deploy the generative AI application in on-prem infrastructure, cooling system and power supplies for these setups can be costly, and which emphasize the importance of using energy efficient infrastructure. Data is the foundation of generative AI, but managing it can be costly. Storing vast amounts of training data requires substantial infrastructure. Beyond storage, pre-processing data, things like cleaning, structuring, and preparing it for model training requires time, expertise, and also resources. Even after deployment, models often need new data to stay relevant or improve. This continuous cycle of data acquisition and usage create additional expenses, making efficient data management a priority for organization. Training a generative AI model from scratch is also another key cost drivers, which requires thousands of GPU hours. This makes it impractical for most organizations to train these generative AI models from scratch. Another option that we have for organization is just fine-tuning a pre-trained model, which is a cost-effective alternative, but it still requires considerable computational resources to adapt the model to specific needs. Hyperparameter optimization, and where you actually adjust setting to improve model performance, can also further increase cost. These usually involve running multiple experimentation to find the best configuration, adding to the computational overhead. After training and fine-tuning the model, deploying that in production environment requires significant infrastructure. Real-time inferences, where model generate output instantly, demand scalability to handle large user bases. Latency requirements are also another key cost factors. Applications like chatbot or interactive tools usually need rapid response, which often necessitate premium hardware configuration. Edge deployment, where models run locally on device rather than in centralized servers, can reduce ongoing operational costs but increase initial development complexity due to the need for model compression and also optimization. Once a generative AI application is deployed, monitoring and maintenance are essential to ensure it remains efficient and effective. This includes using tools to track model performance, monitor costs, and also ensure data security. Over time, these models may experience drifts, where their performance declines due to changing data patterns. Updating and retraining the model to address these drifts include additional costs. Finally, debugging errors and refining systems require ongoing effort from skilled teams, adding to the operational expenses. Another cost factor, which is licensing and API cost. Many organizations usually rely on APIs from providers like OpenAI or AWS or Azure to access generative AI model. These APIs offer convenience, but at the same time, they come with recurring fees, which can add up over time. Licensing costs for commercial software or frameworks also need to be considered, especially for businesses that rely on specialized tools or commercial models. Compliance and security. Generative AI often handles sensitive data, making compliance with regulation like GDPR or HIPAA critical. Meeting these standards can involve costly measures such as ensuring data transparency and traceability. Data security is also equally important. Protecting sensitive information requires investment in encryption, monitoring system, and also secure infrastructure to prevent breaches. While these measures are expensive, they are crucial for maintaining user trust and also avoiding legal issues. All right, so we covered the key cost driver of generative AI application. Now let's talk about total cost of ownership, or TCO. If you are working on any sort of AI project, understanding TCO is critical because hidden costs can easily derail your project plan. TCO refers to the total cost of the total sum of all expenses tied to a specific AI project, not just to the upfront cost, but also things like infrastructure, licensing, and operational expenses. Many companies dive into AI without fully accounting for these types of costs, and they end up facing delay or overspending. The first step in managing and understanding TCO is to defining the scope of the generative AI project. Think of this as setting the blueprint for everything else. If you get the scope wrong, your risk of overspending and missing deadline is high. So to get this and define this scope of the AI application, start by identifying the use case. Ask yourself, what is the purpose of this AI application? For example, is it generating customer service response, creating marketing visuals, or analyzing data? Make sure that the use case aligns with the specific business objective. For example, a customer service chatbot goals might be to reduce call center response time by 30%. Next, estimate the scale. Consider how many people will use this application, and how often they'll use it, and where they are located. For example, a chatbot for a global retail brand will need to handle high traffic and work in multiple languages compared to one for a small local business. Finally, define the project timeframe. Will this be a short-term project like an MVP that you launch quickly, or a long-term deployment and planning expansion? Keep in mind that the extended timeline often means higher cost. Think of it like a construction project. Delay in building a house lead to extra labor and also material expenses. All right, now that you scope the project, the next step is to break down the cost involved. Generative AI applications usually have 6 major cost categories. Firstly, development costs. This includes model training, customization, and data preparation. For example, fine-tuning a GPT model on a specialized data can easily cost tens of thousands of dollars in computing resources. The second cost is infrastructure. This is the hardware or cloud services needed to run your AI model. You might be choosing between on-prem server or renting cloud services. Each has a trade-off. On-prem may have a higher upfront cost, while cloud services can scale but come with recurring fees. The third component is operational costs. These include monitoring, maintenance, and unexpected spike in usage. For instance, imagine your AI model experiences a surge in API requests during a holiday promotion. This could cause a sudden increase in expenses. Fourth, licensing costs. So if you are using commercial models like certain version of GPT, you need to pay for the access of those systems. Fifth component is team cost. AI development required skilled professionals like data scientists, ML engineers, and DevOps specialists. Salaries for these roles can be significant. So think this figure annually for top talents. Finally, the indirect costs. This category includes things like compliance with data regulations, downtime due to a technical issue, or training employee to use the system. To make this reliable, you need to just make sure and keep in mind that the proportion of all these components may vary depending on the project. Now that you have a very good understanding of the key cost component of TCO, you need to then start to quantify and analyze cost. Start by breaking costs into measurable unit. For example, if your generative AI application generates text, measure cost per token. For image, calculated per image. This helps make abstract costs more concrete and comparable. Next, look at market pricing trend. For example, GPU may cost $2 or $3 per hour on a cloud platform. An API call may cost 0.0004 per token. These figures can vary based on the providers and demand. So keep them up to date. Keeping those up to date is crucial. Then you need to start to compare these and analyze those to understand what would be the best configuration for your generative AI application. Using all these different metrics, you need to calculate the TCO, which is going to include the sum of all those costs related to the development, infrastructure, operational, and licensing, and so on and so forth. And then one thing that you need to also consider, you need to do time period analysis. Assess how costs change over time. For example, in the short term, the cost per user may be high because you are building the system. As you scale to 100,000 users, fixed costs spread out, reducing the per user cost. After you have a very good understanding of TCO and you know how to quantify and analyze that, the very next step would be to do a sensitivity analysis. So start by defining the sensitivity analysis. It's about testing how changes in key variable is going to affect your TCO. For example, imagine your application token usage double due to a surge in user activity. How does that one is going to impact the total cost of ownership for your application? Or what happens if your cloud provider raise prices by 20%? Sensitivity analysis help you to prepare for those scenarios. Next, move to comparing these different deployment models. Many companies choose between on-prem infrastructure and cloud-based solution. On-prem offers control and predictable costs, but may lack flexibility for scaling. On the other hand, cloud options like AWS or Azure may provide scalability, but often comes with higher variable costs. We're going to go have a quick code example that going to show you how you need to just calculate your total cost of ownership and also run this sensitivity analysis to better help you make an informed decision on the deployment model that you need to choose. So let's just quickly go to that example. All right, now let's quickly go through this example of how you can easily just calculate the cost of your generative AI application and also run sensitivity analysis. So we have a very simple use case here. So we're gonna just calculate the token usage. So let's say you are using the GPT API and you have an application that consumes the model. And then let's say these are some pricing parameters for your prompt cost per 1K token. So as you know, like if you are using those APIs, you usually pay for both input token and also the generated token. So let's consider these as like numbers, but then definitely check out the OpenAI website for the latest numbers. Also, let's say for this specific application, we have daily request of 1,000 and also the average token per prompt is around 300. And also, let's say this average completion token is around 500. So we define this function to quickly calculate the total cost and also prompt cost and completion cost. So using those function and also those numbers, you can easily just calculate the baseline cost for your application. So for this specific case, the total token cost is 1,170, and also the prompt cost is 270, and then the completion cost is 900. To do a more like a kind of sensitivity analysis, so let's say the daily request range is just changing with this within this range between 500 to 2,000, and also the prompt token range, also the average is actually varied from 100 to 500, and then the completion is varying from 200 to 800. So we just do a like a very simple metrics to just get those numbers. So for each individual of these values, we just calculate the total cost, and then we just capture those. And then let's say for any sort of optimization through prompt engineering, we are able to just reduce the prompt and completion token by 30%. We can easily just get those numbers and see how these optimization actually can help us to do like to reduce the total cost. So for this specific case is we got nearly 30% cost saving when we are running that. And then we can visually just do this and understand how different like prompt token or even completion token can help us reduce the cost. And then this map can help us better understand how the variation in those can help us to just make cost saving. So this is like a very simple kind of like sensitivity analysis that we've done here. So which can give you like an idea what you need to consider and how you need to calculate the TCO and also run this sensitivity analysis. I'm going to add the link to the Git repo that include this example in the description. All right, to wrap up, let's revisit what we covered. First, we talked about the key cost drivers of generative AI. This set the stage for cost management in those applications. Next, we covered the total cost of ownership or TCO and broke down the cost component from development and infrastructure to team and indirect cost. Then we learn about how to quantify and analyze cost using measurable units, market trend, and also a simple TCO formula. Finally, we explored sensitivity analysis and deployment comparison to prepare for cost fluctuation and also make informed decision about hosting model. And one last thing to remember, managing TCO is not just about saving money. It's about ensuring your AI projects are sustainable and scalable for the future. Thank you.